Hi guys, and welcome back to the ACE Academy. In this video, we will be looking at how to sketch a linear function using the equation and also how to find the equation of a linear function using the given function. Okay, so the first thing that we're going to do is we are going to sketch a linear function. Now there's an equation on the screen currently, and that is y over 2 is equal to x plus 1. Now you will get something similar in your paper, hopefully, and here's how you'd solve this. Our first step when working with a linear function, or any function for that matter, is to write down the standard formula. In this case, because it is a linear function, the standard formula or the standard equation is y is equal to mx plus q. Now, there is something that is wrong with this equation, of course. We can see that it is telling us that y over 2 is equal to x plus 1. Now, when we are working with any linear function, our first step after writing down our standard equation is to make sure that the equation that has been given to us is in standard form. Now, we can see over here that the equation that has been given to us is y over 2. Now, that is incorrect, because we cannot plot this function as is. We don't like working with functions that aren't in linear form. So in order to get this function to our standard linear form, we would multiply both sides of this equation by 2. And that would give us y is equal to 2x plus 1. Sorry, plus 2. That's my error. Y is equal to 2x plus 2. Right, now this is a function that we can plot, of course. Now, here's where I'm going to break your world. When it comes to drawing a line, we only need 2 points. We need 2 points that the line will go through, and that would give us a straight line. So, in the same sense, for the linear function, we only need 2 points. And now, because we're working with a linear function, there is an easy way to obtain these 2 points. That is to find our x and y intercepts, right? Because we know that the function is definitely going to be going through those 2 points. Now, from the previous videos, I'm sure that you have noticed that the x-intercept is the point at which the function passes through the x-axis. It's that x value at which the function passes through the x-axis. And the y-intercept is that y value at which the function passes through the y-axis. Now, the x-axis has an equation of y is equal to 0, because it is a horizontal line that passes through 0 forever. It's independent of x. And the y-axis has the equation of x is equal to 0, because it is a straight vertical line that passes through the origin, passes through 0, and continues forever. It doesn't change. It's independent of x, right? So, with that being said, we know that one coordinate of our x-intercept, which is going to be our y value of the coordinate, is going to be 0. So using that bit of knowledge, we are going to go ahead and look for our x-intercept. So for the x-intercept, we will let y equal to 0, because the y value of the x-axis is 0. Putting that into the formula that we have worked out, we will get that 0 is equal to 2x plus 2. Simplifying that, we get negative 2x is equal to 2. And taking that a step further, we will get x is equal to negative 1. Right, so we have successfully obtained our x-intercept, which would be negative 1. So I'm going to just plot that on the Cartesian plane quickly. Right, now with that same approach, when we are finding our y-intercept, we would of course let x equal to 0, because the equation of the y-axis is x is equal to 0. Substituting this point into our equation, we get y is equal to 2 times 0 plus 2. And simply 2 times 0 is 0, and we adding 0 to 2, which will give me an answer of positive 2. And if I go onto the function, onto the Cartesian plane, I can plot that point. Right? I can draw a nice straight line through these 2 points. And we have successfully drawn our function. Right, that is the linear function that we have just plotted. Now, what I want you guys to notice, just like I've stated in the previous video, that the q value, so that is the constant that we are adding, it has no x attached to it, right? So the plus 2 is actually in fact our y-intercept, and we can see that. Even when we substituted in 0 for x, we obtain an answer of positive 2, and that is our y-intercept. It's that simple, guys. Now, with that being said, of course, we can obtain any linear function with those 2 points, that being our x-intercept and our y-intercept, right? Now, it's time to move on to the next part of this video, which would be obtaining the equation of a linear function when we are given the function. All right. Okay, guys. So now we have been given a linear function on a Cartesian plane with only 2 points that we know, right? And we are asked to go ahead and find the equation of this function. The 2 points that have been given to us are the x-intercept at -3 and another point somewhere on this function that has an x value of 1 and a corresponding y value of 7, right? So our first step in this situation would be to calculate the gradient of this function, okay? And this can be done using the equation for gradient, which is m is equal to y2 minus y1 over x2 minus x1. Right, in this case, I'm going to call this point over here, the point further towards the right, point 1, and I'm going to call the point towards the left, point 2, right? And now we're just going to substitute in the corresponding values, right? So in this equation, this would now become m is equal to zero minus 1 all over -3 minus 7, right? So those are our points. Now simplifying this, I'm going to get -1 over -10. Let me show that to you guys. So that will be -1, 0 minus 1 is -1, minus 3 minus 7 is -10. And the two negative signs will cancel out, and I will get 1 over 10. Which is in fact 0.1. So I have a gradient of 0.1 in this case. Now I can keep this to the side so I know I'm working with it. And we are going to move on to the second step. So now that I've found the gradient of this line, I can now work on getting that last bit of information for the formula y is equal to mx plus q. So I found the m value, now I need to find the q value. And the way we would obtain this is simply by substituting in any 1 point into the formula. So from the previous question, I know that m is equal to 0.1. So I'm going to put 0.1 down. Right. And I'm going to substitute in an x value. So I'm going to use the point that was given to us on the function. And that x value would be 1. Right. And then we're going to complete the equation with a plus q. Right. And on the left hand side of the equation, our y value for this point is 7. Right, so this equation is now 7 is equal to 0.1 times 1 plus q. If I simplify that, I will get 7 is equal to 0.1 plus q. Now, of course, I don't know my q value as yet, and 0.1 times 1 is 0.1. Now, I want to isolate q. And the way I'm going to do that is I'm going to take any whole number that is on the right hand side and I'm going to move it to the left. And by basic manipulation, that becomes 7 minus 0.1 is equal to q. And hence my q value is now 6.9. Now that I have the m value and the q value, I can go ahead and write the complete equation, which would be y is equal to 0.1x plus 6.9. And there you have it. That is how you obtain the equation of a function from the given picture and 2 points. It's that simple, guys. Alright, that is it for me. That is it from me for linear functions, and I hope to see you guys for the quadratic functions part of functions in grade 10. All the best and good luck.